AI today is not just creating amazing images and videos or generating code, it's even solving complex mathematical problems. It's revolutionizing every industry that we can think of, and cybersecurity is on the menu as well. But along with all of these amazing benefits do come a lot of security risks. The same AI that can help us detect never before seen cyber attacks can also be used to generate very convincing phishing emails or write malware that is extremely difficult to detect. So, how do we navigate this world? How do we build AI applications and systems that address these vulnerabilities and are trustworthy and reliable? Hi, I'm Mookhey. I have been in cybersecurity for over 25 years. And in this course, we're going to go from 0 to 100 in exploring this amazing intersection of AI and cybersecurity. It's not just going to be theory, we're going to actually build our own apps. We're going to test them. We're going to go into the code, and then we're going to secure those very apps. So if you're interested in learning more, grab a coffee and settle in. In this first video, we're going to demystify the concepts of artificial intelligence. Before we learn to hack and secure a technology, it's important that we have a fairly good understanding of what the underpinnings of that technology are. And it's also interesting to look at this journey of artificial intelligence, which isn't new at all. So let's take a little bit of a step back into history. The evolution of artificial intelligence could be said to originate from the 1950s by this very famous mathematician called Alan Turing, who created what we call the Turing Test, which is essentially to decide if a computer system is behaving in a way that makes it indistinguishable from the behavior of a smart human. And if it does so, it is said to have passed the Turing test. The term artificial intelligence probably was officially first used in 1956 in the Dartmouth conference. Unfortunately, the promise did not deliver in terms of the hype. The computers back in the day were just not powerful enough, and we didn't have these massive amounts of data that we have today thanks to the internet. And so the world of artificial intelligence went through what we call an AI winter, which wasn't the first. There were many such winters. Cut to the 1990s and 2000s when we come across the term machine learning. Instead of trying to write hundreds and thousands of rules that would mimic human behavior, machine learning is the concept of algorithms that look at data and then decide what patterns seem to appear from that data. The best example is the spam filter in your email client. We haven't coded hundreds and thousands of parameters of what spam email looks like. Instead, we've taken an algorithm that has been trained on tens of thousands of examples and has figured out on its own what looks like fishy, suspicious, spammy emails. In fact, every time you click on an email and say this is junk or mark it as spam, you're training the algorithm to work even better. The real explosion, though, happened in the 2010s with the concept of deep learning. And deep learning uses a specific family of algorithms called neural networks, which actually mimic the human brain, the structure of our neurons in the human brain to a very large extent. And the breakthrough moment was in 2012. A model called AlexNet won a competition for image recognition, doing better than not only all the other algorithms in that competition, but almost mimicking human behavior in identifying images. And that kind of brings us today to this modern new era of AI, which we call generative AI. And as the term generative suggests, this is not just about detecting patterns, detecting images, it's about generating new content, be it articles, blog posts, code, images, or videos. And this is the world of ChatGPT and Midjourney and VO3 and Google's Nano Banana and all this fancy stuff. So let's kind of demystify all of these different terms that we are hearing about. First, I think, is the big daddy of all the terms, which is artificial intelligence, which means any technology or any system that enables computers to mimic human behavior. Within that, we have a subset, machine learning, which, as I explained with the spam filter example earlier, is about algorithms, which is nothing but a mathematical sequence of steps that, trained on large amounts of data, detects patterns, what's suspicious, what's not. And then we come to generative AI. And what is at the core of generative AI? At the core of it is a new type of algorithm called a large language model. And as the name suggests, a large language model is basically a mathematical algorithm that has been trained on colossal amounts of data. Pretty much everything on the internet, all articles, all videos, all images, everything has been hoovered into this large neural network. And the way that the large language model works is that it is a very sophisticated predictor. Given a sequence of words, what's the most likely next word in this sequence? And when this starts to happen at scale, we see emergent properties come through. Properties that were not evident in the source data, but in doing this kind of prediction, new patterns emerge. And that is why the promise of generative AI actually solving problems faster and better than humans have been able to do so far. And it is not just smart autocomplete, it actually starts to mimic human reasoning. Okay, so we have these what appear to be very powerful systems, but it's not that they come without their own problems. One of the challenges we have with LLMs is that they have been trained on data up to a particular date. So, for example, as we shall see in this course, one of the concepts that we will try to understand is called MCP, Model Context Protocol. If I remember correctly, Model Context Protocol came through in December of 2024. And even now, if you go on Google Gemini and you put an MCP, it does not understand MCP to be Model Context Protocol. It always comes up with different interpretations of what MCP stands for. But Claude, created by Anthropic, also the creators of MCP, obviously understands what MCP means extremely well. And therefore, there are these nuances where you find that because the training stopped on data 6 months old or a year old, the very latest information is not available inside the large language model itself, which is why a lot of the LLMs today supplement by doing web research. They will go and search on the internet to help you answer your question better. The other problem with LLMs also is that they hallucinate. Hallucination is another way of saying politely that they basically lie. They just come up with facts and statistics. And these are so realistic, and we shall see multiple examples of these, that they make you believe in the veracity of what the output is. So, how do we build AI apps that are trustworthy and reliable and consistent in their work? The first term that we will deep dive into in the subsequent chapters is called RAG. RAG stands for Retrieval Augmented Generation. Think of it like giving an LLM a specific textbook on a given subject and saying, hey, in addition to the colossal amounts of data that you have, I also have this very specific set of knowledge I want you to add into your knowledge base, and then use this as the first source of reference when I ask you a question. So think of it like you want the LLM to answer user questions on your corporate policies. But ChatGPT thankfully does not have access to your corporate policy. So you do what is called, you use a technology called RAG, where you take all of your policies and put it into this specialized database, which gets added on top of the LLM's dataset. And then the LLM uses, first and foremost, this authoritative source of information to answer your question. And that's RAG. But humans demand more from their technology. And so just a smart chatbot does not seem to cut it for us. We want these AI systems to take actions. And here's where we get Agentic AI or AI agents. Agents have a few additional components along with the LLM itself. So the LLM is the brain of the agent. It also has access to memory. So it can store information about previous actions it has taken, your feedback possibly on those actions, whether the steps were correct or incorrect. And based on that, it can then reason through a given objective. We shall go deeper into this. We shall build our first AI agent in the subsequent. And finally, when you have a complex problem like cybersecurity, where you have threats and vulnerabilities and compliance and policies and controls, you possibly need multiple agents. And all of these agents have to kind of talk to each other, coordinate with each other. And this leads us to multi agent systems. And we will look at, for example, Google's A2A, agent to agent protocol, which enables multiple agents to coordinate and collaborate with each other and therefore create a highly powerful, very intelligent system that can solve complex problems. So let's recap. We started by looking at the history of AI, talked about the AI winter, talked about the Dartmouth conference, and then the explosion of deep learning, machine learning, and generative AI. And we also looked at what goes into building an AI application that actually works. We looked at RAG, multi-agent systems, and we also looked at what goes into building an effective AI application. RAG, retrieval by augmented generation, AI agents, and multi-agent frameworks. And this is the foundation. From the next video, we're actually going to deep dive into code. We're going to build our first RAG app. We're going to break it apart and we're going to secure it. So if that looks interesting, if you found this helpful, do like and subscribe, share it within your network, and also add in the comments what you would like me to cover in the subsequent chapter. See you in the next video. Thank you for watching.